So, good morning, everyone. Welcome to our maths class. And if you remember, in last class, I have started differentiation. And in this differentiation, first I told you all this formula what we have to use, and then after I started to solve the question. And what I am thinking, and if you remember, you must have seen till the question number 15 we have done. And different type of questions are there where we have to do some simplification firstly, and then after we have to use differentiation. Many several type of things are there. And in this series I told you कि we are having two type of the question, one directly by using the formula and second one directly by using the first principle, or I can say by using definition. So if I'm remember last class we have done many question, but now I'm going to do some more question depend on this differentiation. That's maybe we will use product rule, maybe we will use a quotient rule, whatever is there. That's I'm going to discuss with you people in this series. That I'm going to do first question here, that is question number 16, second part, and then after many more question will be there. 16th second part. In 16th second part, it's written find the ddx of ax plus b whole upon cx plus d. If you remember, in last class only it was discussed कि ddx of numerator upon denominator can be written as denominator is square, denominator into ddx of numerator minus numerator into ddx of denominator. This formula we had learned previously. In our given question, you can see easily that ax plus b is as a numerator and cx plus d is denominator, and we have to discuss about it. So if I'll use that formula, cx plus d the whole square, so I can write here cx plus d into ddx of ax plus b minus ax plus b into ddx of cx plus d. Okay, now cx plus d, a into 1 plus 0 minus ax plus b, c into 1 plus 0. cx plus d the whole square. Okay, and now we have to simplify only, and then you will get your result. I think when I'll multiply by a, I am having a cx plus ad minus bcx and minus acx again, extremely sorry here. Again I'll write acx minus bc and whole upon it is cx minus d the whole square. Once again I want to tell you what I have done here. Denominator is square, denominator into ddx of numerator minus numerator into ddx of denominator. The differentiation of ax plus b will be a into 1 plus 0. Differentiation of cx plus d will be c into 1 plus 0. And now the simplification part, when I multiply by a, then acx plus ad. When multiply by c here, again I'll get acx minus bc. Now you can see acx and acx can be cancelled, and we are having very clear thing now, ad minus bc upon cx minus d the whole square. This is our first question for today, and now too many questions are there what we have to do like that. Question number 18, second part, you can see again we are having the quotient. We have to use quotient rule only. Question number 18, second part is there. I'm having ddx of ax square plus bx plus c whole upon px square plus qx plus r. It can be written as px square plus qx plus r the whole square into px square plus qx plus r. Now you may write here px square plus qx plus r. Now it can be a into 2x plus b minus, again it is ax square plus bx plus c, and that is 2px plus q whole upon, I may write here px square plus qx plus r the whole square. Now, you can see that differentiation part is over. Now we have to do just simplification, I can say mathematical simplification, and then you will get your result. In this series, when I will multiply by 2ax to p, I will get here 2a px cube. Then multiplying here 2a q x square. Then multiply here 2arx. Then bpx square bqx br. Okay, now with negative sign 2apx cube 2p p b, it will also with negative sign, x square and minus 2pcx. Listen me carefully what I want to say. Now from q, if I multiply minus aqx square minus bqx and minus cq, and whole upon that denominator will be there px square plus qx plus r the whole square. Now you can see carefully 2apx cube, 2apx cube can be cancelled. 2aqx square, and here I am having bpx square, here I am having bpx square. arx, it's okay. bqx, bqx, they can be cancelled. And then after you can see 2aqx square minus aqx. So you have to simplify. Since this is not there, that is the last line of this one, then you can easily get the result. Okay. Now after solving this question, few more things are there what I want to discuss with you people, where we have to use the product rule, and then some question actually I want to do depend on the first principle. Okay, that question number 25 is there, where we have to apply first principle only. So let's solve some more question, then after I'll move there. Now, as I told you, a few more questions are there with us, and these questions are depend on. Okay, 19 second part you can do. See, 19 second part is there. D dx of a upon x to the power 4 minus b upon x square and plus cos x. When I'll simplify, I can write d dx of a upon x to the power 4 and d dx of b upon x square d dx of cos x. Very carefully you can see. Sometimes students are thinking ki, okay, it is numerator, it is denominator, and we can use it. You may use, but what I am thinking, another way is there. A is constant, it can come outside, and d dx of x to the power minus 4 I can write. B can come outside, d dx of x to the power minus 2, and the d dx of cos x is minus sin x. It is A minus 4 into x to the power minus 4 minus 1 minus b minus 2 into x to the power minus 2 minus 1 and minus sin x. Now what can I write here? Minus 4a upon x to the power minus 5 plus 2b upon x to the power, sorry, it is plus because x to the power minus 5 will be there. When I'll write like that, it will be positive. Here minus 3 will come, and like that. It is sin x. This is the result. This is our result, and it was in easy question. Now few more questions are there where to use product rule, and then after in trigonometry I can say product rule will be used in trigonometry, and then after we are moving for some other question. You can see question number 20 is there. I'm having d dx of x to the power 4 inside bracket it is 5 sin x minus 3 cos x. So here bracket will be used at the first function, and that one function, and x to the power 4 will be used another function. I can take this one is the first and this one is the second. So that formula is there, x to the power 4 into d dx of 5 sin x minus 3 cos x plus 5 sin x minus 3 cos x and d dx of x to the power 4. Okay. You can see carefully x to the power 4, it's a 5 cos x minus sin will be plus 3 sin x. Then after already I am having 5 sin x minus 3 cos x, and that is 4x cube over. You may just write one more line to simplify it, otherwise you can leave here, no problem is there. Now you can see one question is there, d dx of, it's a question number 23 second part, d dx of sec x minus 1 upon sec x plus 1. Not do too many way are there to do. Either directly we will use that differentiation, or we can simplify firstly and we can multiply by sec minus 1 in numerator and denominator, then denominator will be 10 square x. But what I am thinking, directly we can do. If directly we will use the differentiation formula, simply I can write sec x plus 1 the whole square. Here I can write sec x plus 1 and d dx of sec x minus 1 minus, it is sec x minus 1 and d dx of sec x plus 1. Now I had used formula. I had used quotient rule, I can say. And now simply what should I write? You can see sec x plus 1. The differentiation of sec x is sec x tan x and then 1 is 0 minus sec x minus 1. This is again sec x tan x whole upon sec x plus 1 the whole square. And now we can simplify. When I'll multiply here, I'll get sec square x tan x plus sec x tan x minus, again I can write sec square x tan x plus sec x tan x and whole upon it is sec x plus 1 the whole square. I think they will eliminate. And now I am having 2 times the same thing I am writing here. It is 2 times sec x tan x whole upon sec x plus 1 the whole square. This will be the our result. Hope you are getting all these things. And now after doing almost each and one more question is there where we have to use I can say quotient and product rules both together. Okay, this is the last question in this one, and then after one more things are there where we have to use first principle to solve the question. That question number 25, there are 8 part, and in each and every part I can say we have to use first principle to find the derivative of this one. We will not directly use the formula. So that question number 24, last one you can see, and then after I am moving to 25. Now, the question number 24th second part you can see. Question number 24th second part, it's written d dx of x sin x whole upon 1 plus cos x. Listen me carefully what I have to do. Here you can see this is the denominator and this is the numerator. When I use quotient rule, no problem, we can use. But during that, when we will use this quotient rule, we will find that we have to use product rule also. Let me tell you how. When I write here 1 plus cos x the whole square, here I'll write 1 plus cos x, and d dx of x sin x minus x sin x d dx of 1 plus cos x. I can write easily, no problem is there. Now, it is 1 plus cos x. Here I can write first into second. X into cos x plus sin x into 1. What I have done? First into second differentiation plus second into first differentiation minus x sin x. It is 0 minus sin x whole upon it is 1 plus cos x the whole square. And now you can multiply to simplify it. It is x cos x plus sin x plus x cos square x plus sine x cos x. And now here I can write minus x sine x plus x sine square x, and that can be written as 1 plus cos x the whole square. This one and this one can come together. Okay. And rest of the things will be, if I take this together, x cos square x and x sine square x will be common, and then simply I can see that sine square plus cos square x will be 1. I may write here x plus x, again I am taking this and this together. So if I take x common, I'll get here cos square x plus cos x and minus sin x. So I had got 2, 3, 4, 5, and now the last term is there. It is plus sin x I think I'm doing some mistake here. That x sin x should not come. Let me check again. X cos x and sin x, it's okay. Then cos square x into x and sin x. This term will not come because that minus x sin x into 1 is 0. Only that much will come, plus x sin square x. So this will not come here. I can write in this way. And plus the constant one will be sin x into cos x, and whole upon I can write 1 plus cos x the whole square. This will be our result, and if it is required we can do some more simplification. And now as I told you, one question is there where we have to use what I can say first principle, where we have to use first principle to solve the question. Let me do this question here. So question number 25 is there, and there are, as I told you, 8 part. In few parts directly means single function is there, and but in one part, that 8 part, I can see there are again the product of two function is there, but we have to apply first order derivative. So first of all, I'm just taking one easy question, and I am just trying to tell you how to use the first order derivative. So this is the question number 25th, 1st, 2nd, 3rd and 4th. Even 7th also same type of the question, then 5th and 6th are the same type, and 8th is a little bit different. So how to do? As you know, when I am writing that's differentiating by the first principle, we used to write f dash x is equal to limit h tends to 0 f a plus x plus h minus fx upon h. This is the standard formula, as I told you in a previous exercise also. Two things were there. That first one, if I want to differentiate a given function by first principle, I'll use this one. And the same thing, if I want to find the derivative of the given function from the given point or on the given point, suppose that it was c. So I took here f dash c is equal to limit h tends to 0 fc plus h minus fc upon h. These things we learn in first exercise, in previous exercise I can say. Now here you can see, if I am talking about the question number 25th first part, I am having fx is equal to sine x plus 1. This one I am having. So fx plus h will be written as sine x plus h plus 1. These two things are there. And now to differentiate it, what can I write? If I want to find f dash x, I may write limit h tends to 0, fx plus h minus fx whole upon h, and then after it is limit h tends to 0, sine x plus h plus 1 minus sine x plus 1 and whole upon h. This is the question in front of you, and then after for a few seconds you can forget about the derivation, or you can say differentiation, and now we can think about the limit. Here you can see we have to apply limit only. When I will put h is equal to 0, sin x plus 1 minus sin x plus 1 will be 0 upon h, that is also 0. So 0 upon 0 case will be there. So what should I do? I can simplify it with the help of using that trigonometry identities. If I take this one as a c and this one as the d. So we had learned one thing, sine c minus sine d is 2 cos c plus d upon 2 into sine c minus d upon 2. So it can be written as 2 cos x plus h plus 1 plus x plus 1 upon 2 into sine x plus h plus 1 minus x minus 1 whole upon 2, and that whole upon h will be there. It may be written as limit h tends to 0 cos 2x plus 2 plus h. It can be x plus 1 plus h by 2. And here you can see they can eliminate, and I am having now sine h upon 2, and if this 2 will come here, this is also h upon 2. Actually purpose is there. Purpose is like that I can write it, its limit h tends to 0 cos x plus 1 plus h upon 2 into limit h tends to 0 sine h upon 2 and h upon 2. This is 1, and now 0 cos x plus 1. This is the result. The differentiation of sine x plus 1 will be cos x plus 1. That is directly also we can do by the using formula, but here we had used it, used the first principle, and then after I have done this question. So what I am thinking, first, second, third, and fourth part will be done like that. Now in fifth part, we are having square terms. We are having sine square x. So what should I do to find the differentiation of sine square x or cos square x by the first principle? Let me tell you again. Here I am having fx is equal to, that is the fifth part of this question, sine square x. Definitely fx plus h can be written as sine square x plus h. If I want to find f dash x, if you want to find f dash x, I may write here limit h tends to 0 fx plus h minus fx upon h. Sorry. Now limit h tends to 0, it is sine square x plus h minus sine square x and whole upon, I may write here h. Now it is up to you what you want to find. If you remember, in trigonometry only one formula was there, that is sine a plus b into sine a minus b, that was written as sine square a minus sine square b. Again I am repeating myself, sine a plus b into sine A minus B can be written as sine square A minus sine square B. Here you can see if I am taking x plus h as a and x as a b. So we are having now sine square A minus sine square B. And if I use formula limit h tends to 0, what can be written as sine x plus h plus x into sine x plus h minus x whole upon h. This is now limit sine 2x plus h into sine h upon h. Limit h tends to 0, it is sine 2x plus h. Limit h tends to 0, sine h upon h. That is equal to 1, and when I'll put h is equal to 0, it is sine 2x. This is will be the result. And now today's last question. If the question is given in product form, that the last question is there of 25th. It is given x cos x. I have to find the differentiation of this one, x cos x. So it will be cos x minus x sin x. That should be result, but how to find? That's I am going to tell you. Listen me, all of you, carefully. Here you can see that first one is fx has given x cos x. It is given x cos x, and f x plus has given x plus h and cos x plus h. Now, while using the formula of that f dash x, it is limit h tends to 0 f x plus h minus fx upon h. I can get here limit h tends to 0 x plus h cos x plus h minus x cos x whole upon h. Now what should I do? We can write here limit h tends to 0 x cos x plus h plus h cos x plus h and minus x cos x whole upon h. What I am thinking, it can be written as limit h tends to 0. If I take these two together, x will be common, cos x plus h minus cos x plus h cos x plus h whole upon h. Question can be divided in two parts. The first part will be like that, limit h tends to 0 x, and inside bracket I may use CD formula. So I can write here minus 2 sine x plus h plus x upon 2 into sine x plus h minus x upon 2 and whole upon h. Another part of this question can be written limit h tends to 0 h cos x plus h upon h. This can be considered small. Now see here, I am getting this one. So I may write one thing, limit h tends to 0 x inside bracket minus 2 sine x plus h upon 2. Don't take 2 here. I can write here sine h upon 2 and whole upon this 2 will come here h upon 2. And when I put here h is equal to 0, simply I will get cos x. Here also that can be divided into two parts. Minus, when I put h is equal to 0, that will be sin x. But this will be limit h tends to 0 sin h upon 2 upon h upon 2 will be 1. So I am having now minus x sin x plus cos x. This is the result. So whatever has given at your level, I can say till the class 11th, in differentiation I discuss all these things, and so now we had completed our limit and derivative here. After that I have to start statistic. Okay, and then one more topic is there, probability, and then we will arrange separate classes for the section A and section C. Means that section B and section C is there, and in section B and section C it's optional, I can say, and one have to discuss about the section B, and that one class commerce students have to concern toward the section C. So three chapters are there in this topic, and but before that statistic and probability we have to complete it. Okay, thank you and have a good day.